For the first time in over 5 decades, humanity is preparing to send a crewed mission back into lunar orbit. This preparation is centered at the iconic Vehicle Assembly Building in Florida, a facility designed specifically to house and stack the largest rockets ever built. The countdown to the first launch attempt is already tightening. The designated launch window officially opens on Wednesday, April 1st. Currently, the 322-foot Artemis II rocket is fully assembled. It sits vertical atop its mobile launcher, appearing physically ready for its journey to the pad. But despite the multi-billion-dollar hardware being fully stacked and ready, the entire operation is currently frozen in place. NASA officially halted the rollout to the launch pad, which was originally scheduled for Thursday, March 19th. Teams shifted their target by 24 hours, now aiming for a rollout attempt on Friday, March 20th. It is a striking contrast, a towering, historic megastructure grounded by a minor technical glitch discovered during the very final hours of preparation. What specific failure could be significant enough to stop the most powerful rocket in the world just before it leaves the hangar? In high-stakes aerospace, massive physical momentum matters very little if the internal electrical readiness is anything less than perfect. Engineers isolated the anomaly deep within the rocket's core stage. The failing component was a single electrical harness, a bridge of wiring connecting two major internal modules. This harness is the vital communication link for the rocket's Flight Termination System, or FTS. The FTS is the ultimate safety failsafe. If the rocket veers off its intended path during launch, this system is designed to neutralize the vehicle instantly to protect the public. Because this mission carries a human crew, there is zero tolerance for error in a system designed to handle a catastrophic malfunction. The Flight Termination System represents the definitive hard line between a manageable flight and an unacceptable risk. NASA's response was immediate. Engineering teams identified the faulty harness and replaced it with a fresh unit. With the part replaced, crews are now conducting relentless checks to ensure the new wiring communicates flawlessly with the rest of the core stage. Once the internal engineering is verified, the bottleneck shifts from the hardware to the environment. Mission Control is now closely monitoring incoming weather patterns, as local conditions at the Cape will dictate exactly when the Friday rollout can begin. Getting this rocket to the pad requires both internal engineering perfection and external atmospheric cooperation. The vehicle responsible for this move is NASA's Crawler Transporter, a massive industrial platform that moves on colossal tracks. This machine carries a massive legacy. It was the same vehicle used to transport the Saturn V rockets during the Apollo era. For decades following Apollo, it also carried the Space Shuttle fleet from the VAB to the launch site. The Artemis program operates this hardware alongside a strict safety culture forged through decades of spaceflight, shaped equally by its greatest triumphs and its hardest lessons. This one-day delay is the application of a zero-compromise safety philosophy that has been standard practice for over 50 years. The trek to Launchpad 39B is a slow one. Once the crawler begins its journey, it will take up to 12 hours to reach its destination. NASA intends to livestream this symbolic journey, allowing people all over the world to watch the slow-motion progress of the moon rocket. Every step of this rollout is a prerequisite for the broader goal, returning to the moon to establish a sustained human presence later this decade. The patience to halt an entire mission over a single wire today ensures that when we finally return to the moon, we do so to stay.